All right, welcome back to another MLOps community podcast. Thanks everybody for joining in. I want to give a few quick notes before we listen to the full conversation with Greene and Seoyoon Park about how they were doing calibration at Etsy. So the full story there and what we dive into was thoughtfully surprising to me because I was not so familiar when it comes to calibration and the way that they were able to take this general theme and explain it to me in a way that I was able to understand not only on the infrastructure level, but then on the machine learning level. We got really deep into the weeds and I appreciate that so much. They were all amazing teachers. And so I hope you learn a lot from this. Before we jump, let me just mention that their bios, so we give them the proper respect they deserve when we listen to them. Both of these two are just battle-hardened veterans. They have experience in the machine learning field. I mean, Erica tells us that she has been in ML since 2010, over a decade of experience. That's amazing. And Seoyoon has been working at Etsy, I think he mentioned since 2019. Let me just read their bios real fast for you so you all know what kind of caliber and quality guests we've got on. And so you also know this is a special episode because these two are going to be presenting at Apply. I mentioned it in the talk, but I'm going to mention it again here. The Apply conference is coming up on February 10th. So if you're not registered for that, go ahead and register. I'm going to be emceeing it, and it should be a lot of fun. The link obviously is in the description below. But now let's talk about Erica Greene. She's an engineering manager with a background in machine learning. As I mentioned, 10 years in machine learning. Actually, by now, we're in 2022. Oh my God, 12 years. All right. She's passionate about developing programs and policies that support women and other underrepresented groups in technology. And then we've got Seoyoon Park, a back-end software engineer and aspiring software architect. The guy's super humble. I mean, he's incredible. If you hear these stories, this like aspiring software architect that is downplaying it a lot. He's interested in producing scalable, performant, and fault-tolerant applications. He's also got a great war story about fault tolerance. So wait till the end. He talks about that. And he loves keeping up to date with best practices and industry standards. We are also going to, I should just mention that we're looking for an editor. I don't know how to put this, but not an editor like someone who knows how to use Adobe Premiere or DaVinci Resolve. We're looking for someone who can listen to our conversations and help us pinpoint where the gems are and which parts we should save and add to a highlight reel or make into its own clip. If you are interested in that, we would love to hear from you because right now what we have is a little bit difficult since there are producers and there are video editors out there that do this as their job. The only problem is most of those people are not very, very wise when it comes to machine learning operations. And so they end up either cutting out things that are important or not cutting anything out and then leaving a little bit too much fluff. If you would like to tell us from minute 155 to minute 5, then that's a good spot. We would love to hear from you. We would love to have some volunteers that can just help us polish the diamonds or find the diamonds and pick out the diamond in the rough. That was the thing I was looking for. That was the sentence that I wanted. All right, that's all I got. I'm going to stop blabbering. We've got this cool talk. It's a special Apply conference pre-talk, and I hope you enjoy. Thank you both for being on here with me. I'm excited to get into all of this. I really want to hear all about calibration, so I appreciate you coming on.
It's great to be here.
Yeah, excited to be here and talk about calibration.
Let's start with a little bit of background on who you both are, and then we can get into the calibration piece. So maybe, Seoyoon, can you give me an update on how you came to be where you're at?
Yeah, for sure. So, I started off in Binghamton University with a computer science degree. And my first job out of college, I went to Viacom, where I was just a backend software engineer working on spin up these sites for like Comedy Central, MTV, so on and so forth. After a
Nice.
couple of years, I moved over to a little startup called Signifier, where it was more like big data analytics, where I kind of worked on um, fitting up their front end as well as connecting some APIs together for our clients. And then I moved over to Etsy. So I traditionally didn't have an ML background until I joined Etsy, where I found myself on this team, which was heavily ML focused. But at the time, we were a small team of like 4 engineers, where we kind of had where we had to touch a bunch of parts of the stack, including presentation, the backend, ML. But as we grew, we kind of grew to more of an ML focused team, and that's where all these ML challenges and my ML knowledge grew. So I'm glad to be on this team. Glad to see it grow, and slowly and but surely, gaining some ML knowledge along the way.
There's so many things that I want to jump into on that, but I'll let Erica give us the same question there. Like, how did your journey get you to where you're at right now?
Sure. So I've been working in tech for over 10 years. I was a math major in college, but I had learned to program in high school and sort of took CS classes all the way through college, and was lucky enough to be able to take some graduate classes in ML in college, and really kind of fell in love with it, and ended up applying for a PhD program, going to a PhD program studying ML. This is like 2010. And I loved the topic. I focused on ML and natural language processing, or NLP. Didn't love the grad school program, didn't love my advisor. Ended up leaving after 3 years and going into industry. So Etsy was actually my first job right out of industry. I was a data engineer at Etsy. And then I went and worked at a bunch of other companies. I worked at the New York Times for 4 years, both as a software engineer, and then moved to management. And I've stayed in management. So I am an engineering manager, and I love to work with teams that are building and owning and improving upon machine learning systems. That's sort of my specialty. And so I was very excited to work with what we call the ad ranking team at Etsy, which, as Seoyoon mentioned, was this very small team. Some people had ML background, some people did not have ML background, but I have an ML background, so we decided just to dive in, and it's been great. We've grown the team a bunch, and we've gotten to work on a bunch of really interesting problems, including calibration, which we'll talk about today.
Super cool background, and like kudos to you for getting into ML in those early days. I mean, 2010, that I can't even remember what I was doing.
Nothing we did is relevant anymore.
Yeah, I believe it. I believe it. The amount that has changed since then. Wow. Even just over the last year, I think about how much has changed. And then if I think back a decade ago, or over a decade ago, that's incredible. So I want to just touch on a quick point that you mentioned, Seoyoon, before, like when you started the team that you were on wasn't primarily focused on machine learning, but then it gradually like ramped up to being that. What was that transition like, and how did you need to think about resources? Maybe Erica, this is one for you later on, is like thinking about resources and thinking about the people that you're going to hire as you increasingly become more focused on the needs that machine learning bring, like those inherent needs that are very machine learning specific.
Right. Yeah, I could start with that. So, when we were a team of 4 engineers, not to say we weren't ML focused, but, all of our abilities were kind of stretched thin across all areas of the stack. So we had to take care of presentation issues on like the page. We had to take care of like backend issues, and also like focus on the ML stuff. So at times there were, there were a lot of problems that comes out in ML space that we can't really focus on, or if there's like revenue pressure coming up, then we would have to shift our focus into that. So a lot of times, our focus was directed into various different stages. There was a lot of context switching, which was difficult. But as we started being able to grow our headcount and separate into more of an ML focused team, we were able to focus on those more ML specific problems. Like something that we didn't really look into heavily was like data quality, and we were able to start looking into that. Or other like evaluation centric metrics we weren't able to look into. We started being able to look into that. And then as a result, we were able to shift our focus into improving our whole ML experience by shifting everything to GCP and TensorFlow, which made things a whole lot quicker. And our model experimentation speed and velocity increased by, I don't know how many fold, but as we shifted towards a more ML-centric team, we were able to, shift our focus into most of that ecosystem, right?
Yeah, and I think this is, I think it's a good answer. I'd add to that, like as a manager of the team, companies grow, products that were more experimental become clear winners, and the teams grow, and so it's crazy to think now how small and lean that team was, but this is not uncommon at organizations, and yeah, we did turn a focus to become an ML, what I would call an ML engineering team. That term wasn't even really around at the company that much at that time. And as a result, there's people who had more of a full stack or backend experience that I was asking to focus on this area. And one thing was I asked people if that's what they wanted. I think people can learn a ton, and ML isn't so challenging. It's not, what else is challenging? Like data analytics or like data engineering. There's tons of things that are really challenging. JavaScript at scale. Performant is very challenging. Lots of things are challenging in the engineering world. This is not, I think, any more particularly challenging, but people need to opt in, they need to want to learn it. And so I remember having a conversation with Seoyoon, like, hey, this is what happened. Are you in? And he was like, yes, I'm in. So I was like, okay. So yeah, I got Coursera, lessons comped by the company. I think you could probably speak to. You took a bunch of classes. We spent our one-on-ones going over all of these topics. And then I think the best way to learn is just to do it. So I don't know, we dove in and did it.
Right. If I could add to that, I think a good part of it was support from, the team, manager, being able to just learn on my own. And then, hands-on work with the ML type problems definitely got me get the ball rolling very quickly. Applications that I learned from courses I could apply to my real job. And then, since there was a lot of experienced engineers already within the team, I was able to learn from them, learn how they do things, and just grow quickly. So definitely the support from the team helped me grow very quickly within the team.
And that's so cool to hear, because I know there are so many companies that are in that same position, and a lot of people that come into the MLOps community and they ask, how much ML do I need to know to be an ML engineer? I'm coming from the DevOps realm, or I'm coming from, like you said, I'm a backend engineer right now. What do I need to know? I took an ML course, but it was all just math and statistics. I'm not sure if I really need to dive into that if I want to just help get these models into production. So that's a great question to have. And it's really cool to see that it is possible for an engineer to make that transition. And if there is the support of the team, as you mentioned, and also just the willingness and that hunger from the individual, anything's possible there. I wanted to touch on just one other thing before we jump forward and talk about calibration, which is when you were doing this, when you had the skeleton team and then it started to grow and you start, like you said, the ML use cases weren't necessarily integral parts of the business, but then they grew to be integral parts. What were some early wins that made you realize we can really, this ML thing has legs and we should invest more into it? And Erica, this probably is an easier one for you just because of the visibility that I imagine you had.
Yeah, I think there had long been at the company and at the team an understanding that feature engineering was a win. You could throw more features at relatively simple models, and that was a formula that, while not necessarily deeply innovative, was a way to sort of incrementally improve model performance. When I started on this team, the kind of core models had massive feature inputs, 150 million dimensional, hash, crossed, highly engineered over time.
Wow.
I think the first big win we saw was I sort of made the call that we were going to move to neural networks, and we threw away a lot of that sort of feature engineering and just took the raw features, did the kind of standard playbook for neural networks, look up the text embeddings, et cetera, but didn't add any more features, threw it into a, I don't know, not very large, fully connected neural network, 3 layers, something like that, and that was a big win.
Mm-hmm.
And it was mostly an ops problem. Seoyoon wrote all the data flow jobs and figured out how to wire up the pipeline and get training working in the cloud. And I would say it was almost 90%, 80-90% DevOps data engineering problem, maybe 20% modeling problem. This was not just Seoyoon and I. The team collectively worked on this, and that was a big win. And we were like, wow, we're going to invest in these models, and that has really paid off.
Amazing. And Seoyoon, how did you have the confidence to take what you were learning in these Coursera courses and then in the one-on-ones and then implement it and be like, all right, I'm going to actually, I'm going to merge this, or please, can someone look at my PR request and make sure that everything's good? Because I just think about myself in that position. I would kind of be like, I have no idea what I'm doing, and I'm just kind of YOLOing it here. Let's see. But I'm guessing that you felt like you had it under control enough to try and make these ops problems go away. And so was it like, what was that like, I guess, in the beginning,
Right.
especially when you were first starting out?
Yeah, so I'd say having it under control is an overstatement. I kind of gained the confidence as I was working through Etsy, just because we have kind of like a blameless culture here, especially if things go down. I think earlier in the year, I kind of took the site down by accident with the push. So that was like a learning experience. But,
That's amazing.
through these experiences, just kind of gain, like, we have a lot of offline tooling as well that we can use to like replay traffic, to run through traffic across the infrastructure. So, if we see latency issues, then we know not to push it up, or we could catch it a little bit earlier. Of course, there are unforeseen circumstances, but the offline tooling, in order to test like infrastructure and these new things that we're deploying to prod, we could kind of test out. And then, of course, like, I'm not just going to blindly push it out. There's going to be a whole team looking, especially since this enormous change. We have documents that everybody can look through regarding like architecture proposals, to make sure that the idea is fully thought out before we actually reach prod. So I think reaching prod took a couple of tries, but it wasn't seamless by any means. But with everybody on the team looking at it, it definitely got to the end, and we're still iterating on the product to this day.
Yeah, and I just add like 3 core things is, one, we run everything as A/B tests. So you run on small amounts of traffic. Worst case, you tank, conversion or something on a small amount of traffic, but you only run it for a day and you learn a lot. The second thing is we load test everything extensively and have lots of load testing tools for models. And then the third thing is that we do extensive evaluation offline, and have seen that offline evaluation tends to correlate pretty strongly with online evaluation. And then we had a staff engineer who had worked in the ML engineering space leading this project, and she did a fabulous job as well. So yeah, by the time we got it to prod, I think we had a fair amount of confidence.
Yeah, it was battle hardened by that point.
Yeah.
So I'm going to put a fork in this one, but I definitely want to come back to it. And it is around you taking down the site for a little bit, because we love to talk about war stories. And war stories are probably the way that I think everyone learns the best. And hopefully we get to learn from others' failures so we don't have to go through them ourselves. But let's talk about calibration, because I feel like we've been saying we're going to talk about it for the whole time that we've been talking, and now we're finally getting into it. I think it would be a good start. Maybe, Erica, you could just tell us, what exactly is calibration?
What is calibration? Yes, so calibration is, let me just back up a little bit, which is that oftentimes in machine learning, we are trying to predict something that is very uncommon, sparse, we call it. So we work in the ad space. We have a model that tries to predict whether a listing is going to be clicked or not. And we call it our click-through rate model. And just clicks on a e-commerce site, just in general on the internet, are pretty rare events. We show users lots of different items that they could potentially click on. They're only probably going to click on a handful, if any. And so models can do poorly if you just train on the raw training data when the thing you're trying to predict is very unlikely. Because if the thing you're trying to predict only happens 1 in 100 times, a model could actually do very well if it just predicts 0, not going to be clicked every single time. And so we don't want the model to do that. So a kind of very old classic trick is that you downsample the negative examples. So that means you train on equal parts zeros and ones if it's binary classification. This is what our training data pipeline was like for this click-through rate model, and it works great. And if all you're doing is using the output of the model to rank things, right? If the actual score doesn't matter, just the relative scores between different items matter, then it doesn't matter that you downsampled the negative class, right? It doesn't matter what the scale or the distribution of the output is. And it's fine that the average score of this model is 0.5, even though obviously the click-through rate on a site is not 0.5. But sometimes it does matter. So I'm gonna maybe let Seoyoon jump in about when it does matter, but to answer your original question, the process of calibration is taking an additional process after model training that converts the distribution of the output scores from the model to what we call true probability space, so that the distribution of the scores is ideally as close as possible to the real true distribution of scores. And if your model is not trained on downsampled data, or you're not doing any sampling of your training data, your model probably is pretty well calibrated, although not guaranteed, but it's probably pretty well calibrated. If you are doing something funky with the model training, distribution of labels, then your model probably isn't calibrated. And so the process of calibration, it's not one particular algorithm, not one particular technique. It's just a name for that. Anything that does that converts the distribution of scores from the output of a model to the true distribution of scores. Does that answer your question?
Completely, yeah. So then, I think you touch on why we need it and what exactly it is, why it's useful, right? And then there's different techniques that you can go about doing this, right? And so what could be some of these techniques that we would look into when we want to calibrate our models?
Right. Yeah, I could touch on that.
Can we first,
oh yeah,
George?
go for it.
Yeah.
Let's talk about, I think I did skip over why it's useful. Maybe Seoyoon, do you want to jump in and say why it's useful?
Yeah. So yeah, we could say, as Erica mentioned before, if we're using these scores to just rank certain things where, the actual score doesn't matter between items, then yeah, the output score doesn't actually matter. But let's say we want to use this score for downstream applications, or you using this for a different purpose, for maybe making another prediction on top of it, then that's when it becomes important. So let's just take from a different industry, for example. Let's say we're in the healthcare industry, right? And your model starts predicting, let's say, the probability for an illness, right? And your model starts outputting very optimistic predictions, let's just say 99% for this specific illness, and then the doctor has to make a judgment on that call. Then if your model is not well calibrated, it's hard to judge that, and it's like a mission critical application, so those predictions are very important. And if we make an analogy to our ads use case, if we start using these predictions to maybe like filter out ads that have a low click-through rate and low quality, that number becomes very important, because if we want to set a threshold, we have to set a threshold on that prediction. So whenever we use these model predictions and downstream applications, it becomes very important. One time it came, one relevant use case in our day was that we've been using, sometimes we've been using like model predictions within like a feature set. And sometimes these model distribution scores shifted wildly after changing from like a trees-based model to a DNN, logistic regression. The distribution would shift greatly. And since it's an input to another model, those output scores also shift very greatly. And then there's a lack of observability in that space, which we can go into. But yeah, those are some of the use cases where calibration becomes very important.
And did you figure out why it shifted so much when you changed these different models?
Yeah,
You're just
so, oh
sorry.
yeah, go ahead.
If you look at like what the model training objective is, right, for a lot of these models, the loss function or something, I mean, the model is trained to optimize the loss function, and you're not guaranteed a stable distribution of scores coming out of the model. I mean, that's just, it's not, calibration is not sort of a built in to these different models. You're not guaranteed stability. And even we found with keeping the same, like a neural network model, but updating the features, maybe updating the architecture, and then running the same training through the same training data, the distributions of scores could be significantly different. So it's just not, I guess the reverse of that question is like, why would we ever think that the distribution coming out of these models would be stable? Yeah.
Yeah, that's true.
And there's some interesting papers about
definitely
how neural networks in particular tend to be more poorly calibrated. They can become overly confident, basically, because they're such highly parameterized models. And so there's a great paper, maybe we can throw it in the show notes or something, that really goes through why that might be true.
Right. Yeah, that paper is called On Calibration of Modern Neural Networks, and it goes into reasons why like modern neural networks nowadays, especially convolutional neural networks, are very miscalibrated. Some like advanced techniques like batch normalization also contribute to this because I think the goal is to improve this model performance, which is not necessarily tied to the goal of calibrating a model. So that paper goes into research into modern day neural networks and sees how miscalibrated these models are nowadays. It's a great read.
And yeah, we'll link it in the show notes
Great.
for sure. I think that's a great point. And it is interesting that you talked about this just a few minutes ago, but obviously calibration in this specific use case, you're using it with ads, but it can be used for almost, I imagine, any kind of machine learning model, and it should be. From what I'm understanding, like the way that you're explaining it to me, it's like, yeah, this is almost like a very, very close to must-have when it comes to the different models and how you're using them.
I would say it really depends on the use of the model. If you're using models to rank, let's just say the search context, you have a model, you're taking all the items that you could return from the search query, and you want to rank those items, and just the order matters, right? It does not matter if your model is calibrated, because calibration is a monotonic. We didn't say this, but it's a monotonic function. I think by definition, right? You don't want to change the order of the items, the scores of the items. We just want to shift the distribution. So we don't want to like take something that was given a really low score and make it given a very high score. That would decrease the accuracy of the model. So in that case, it doesn't really matter. But if you are going to actually use that score for something, like you have a content moderation system, you have a something in the healthcare space where you're making you have some cutoff and you're making some decision based on the output, or if you're ever taking the output of two ML models and multiplying them together, now the distribution does matter.
Okay, cool. Well, thanks for clarifying that one. Now, we talked about the ML side here. What about the implementation side? What does that look like? And Seoyoon, can you talk to me about what it was like after the calibration phase, or how you implemented calibration within the whole workflow?
Right. Yeah. So calibration, if we talk about how to calibrate a model, you're supposed to like grab like a subset of training data or any subset of data that holds your true probability distribution. And then you basically train another layer on top of your base model. So there's a variety of techniques you can use. The widely popular ones are Platt scaling and isotonic regression. And each of those are post-processing techniques where you can train this specific layer after you train your base model. So what you do is you freeze your base model weights, and then you basically train this layer to learn specific weights. For Platt scaling, it's a parametric layer. So that layer does have to learn weights based on some subset of training data. So what we did with TensorFlow, it came to be pretty easy after we migrated towards it. We basically just reloaded our old model and then attached this final layer on top, and then trained that final layer before outputting sigmoid activation. And then in isotonic regression, it actually just finds various buckets of predictions and then outputs a constant prediction in a monotonic fashion, so that ordering doesn't change. So we haven't explored isotonic regression yet, but it's relatively simple for Platt scaling and TensorFlow. So we were able to just throw that into our ETL pipelines to just output a subset of data for calibration, and then the rest is pretty simple in terms of deploying. The tricky part is just now with these calibrated scores, within the ad space, in order to rank our listings, we actually have this ranking formula where we have the click-through rate prediction and the prediction of another model. We kind of combine it in a nonlinear fashion to order these ads in terms of relevance, revenue, balancing objectives. But now, since the distribution of these model outputs are different, some of the ordering changes in the final output. And this has direct implications to costs charged to sellers and the ads that appear on Etsy. So that's where the tricky part comes in, and that's where a lot of the analysis took place when we launched this project.
Okay, and there's something really interesting around this, and that's like the metrics, and you mentioned it on the last answer too, and it's like, how are you evaluating the metrics? How are you evaluating what to look for when you are calibrating? What is your sign of truth, or what is your source of truth, really, when you're looking at this? How do you know if it's good or bad? And maybe, Erica, I'll ask you this one.
Sure, yeah. So calibration, as I mentioned before, is a monotonic function, or we were applying a monotonic function, which means that the ranked ordering of the eval examples shouldn't change, which means our primary metric that we look at when evaluating, we're doing binary prediction, click, not click, is AUC, and that is a ranking metric. So if the order of the results based, the model score ordered by the model prediction doesn't change, then the AUC shouldn't change. So the first thing we checked was like, let's confirm that that is true, and that was true. So our offline AUC was the same. The second metric that we looked at is what's called the calibration, which is really simple. It's just the predicted, the percent of true clicks, ones, in the true eval set divided by the predicted, true label from the model. So you want that ratio to be as close to 1 as possible, right? Like we don't want our model to be over predicting the click label. We want it to be the same ratio as in production. And so we graph the calibration score. And then we also, and maybe Seoyoon, you can jump in about this, look at normalized cross entropy. Is that correct?
Right. Yeah, there's a variety of other things. One is normalized cross entropy, which basically measures like how close your output distribution is similar to the distribution seen in the eval data set. So as this metric goes closer to 0, the output distribution is closer and closer to what the distribution you see in the eval data set. So that's one metric we closely followed. And then another thing we can visualize is something called a reliability diagram, where it outputs a graph of the predicted probability versus the actual rate that you see in the eval data set. So it's basically just a graph where the identity function is what you want to see. And if you see overconfident predictions, you would see a graph that's closer to the x-axis. And then if you see a line closer to y-axis, it's underconfident in its predictions. And with this, it's kind of more granular than the calibration metric, because you will see where the performance starts to go wrong in terms of, is it this bin in the higher end of probability spectrum that's being overconfident or underconfident? Whereas the calibration metric gives you an overall sense of model calibration. So you can see where this overall metric, it can go wrong if it balances like overconfident predictions in one end and underconfident predictions in the other end. It'll still reach 1. But the reliability diagram, you'll be able to see where it's overconfident and underconfident in various bins of probability space. But yeah, I'd say.
And so now,
Oh yeah, sorry. I was just gonna say, yeah, those 3 metrics are basically the metrics we use to define calibration and see how well it does for us.
and so what I was thinking about is, because I know we talked before we hit record about the testing of this. Is that part of it, or did you have something else that was added on top of that?
So yeah, so this only measures like calibration of the model, and traditionally we've been very focused on improving model performance for like a click-through rate model, but there's another component to this, which is our ranking function, as we mentioned before, which kind of does a nonlinear combination of these model scores and generates a sorted list of the ads we want to show. So now, even though we improve the model, we might not improve like the final ordering of these ads. And that's where we kind of lacked visibility in the past, where we haven't really taken much deep dive into, and where we didn't have too much offline evaluation metrics for. And in current times, when we were working on calibration and trying to assess the candidate set, we started implementing these new offline evaluation metrics, just like regular precision and recall based on historic click and purchase data to assess whether our new candidate set was faring better or not. And in terms of basically experimentation and just testing out these changes online, we have an A/B test framework where we can deploy this new framework online and then just see the changes in engagement rates across Etsy based on the small traffic versus the large traffic to see if it's an improvement to our system.
Okay, this is fascinating stuff. And I know that we also had mentioned there was a little bit of a bug that held you up for like 4 months in TensorFlow. Erica, can you talk to us about what that was and how much, and like, how did you end up finding the bug? What was the fiasco about? What
Yeah, I can give the
happened
high
there? Give
level.
us the
Seoyoon was the
story.
one on the Google support emails for the duration of that. Yeah, I mean, the
Okay.
way that this is implemented in TensorFlow, in particular, we're using the Keras library in TensorFlow, is that we just use a fully connected neural network. We can take the neural network, train it like we normally train it, and then we learn weights, right, for the entire network, and then you can freeze those weights and then add an extra layer on top. Plat scaling is just a single variable, like a single variable, single bias offset, so 2 parameter logistic regression function. So it is just a layer on top of that neural network. You have to learn 2 parameters, and you train it on not downsampled training data. And so it's a second training step. So you take your model, you train it, then you freeze those weights, you add a layer, and then you train it again, but on a different set of data, without downsampling of the negative class. And then that final thing gets frozen packaged, sent off. And I can't even remember exactly. Somehow saving that and then unsaving that, right? Was that the problem, Seoyoon? That seg faulty?
Right. So we ran into a seg fault issue. This was in TensorFlow 2.3. And this was like, I think, early stages of TensorFlow before like wherever we're at now, 2.7 or something. We were kind of like early adopters of TensorFlow 2 in production. And I think there was an issue with loading a large parameter model, saving it, and then reloading it. Because we did achieve calibration in our first pass ranking stage with a less complicated model. So we thought it was going to be a seamless transition to the second pass models, but apparently it wasn't. Exactly.
Never that
Exactly.
easy.
We've been we've been running into segmentation fault issues, which was very confusing because the first pass was very seamless, and yeah, something to do with like loading these large parameter models and GPUs caused to be an issue because the CPUs didn't cause issues. So we went back and forth with Google for about a couple of months before we came to a patch which they were able to resolve. But I think lesson from that is kind of, we did have to upgrade our TensorFlow versions for a good reason, because they had features in there that we needed to continue our work. But being early adopters of some technology, it proves to be, very, problematic at times, especially if, it's very new,
Yeah.
maybe in GA. I'm not sure what, level of
Well,
support there was at that time.
yeah. Yeah. Also, I mean, it's a complex issue when it's hard to debug these issues when you're using TensorFlow, but then it's running on particular hardware, right? So you mentioned this wasn't a problem on CPU, but it was a problem on GPU. But these models are very large. It's very important for us to be able to train them and run them on GPUs. And then we were training them in the cloud. So there's a whole bunch of infrastructure and technology and libraries there. And so piecing apart what was actually introducing the error and narrowing it down took a fair amount of time.
Yeah, just being a
Yeah.
detective and going through like
Yeah.
Sherlock Holmes,
Yeah.
right? You're trying to figure out like, well, is it this? It seems like it's working all right, and really having a lot of surface area to cover. So I can totally understand that, and it is interesting, this trade-off that you get. Hey, we need the new version of TensorFlow. Like we want to go to TensorFlow 2.0 or whatever, TensorFlow 2.3, I think you mentioned. But then you see that there are certain things that we have to rethink about, and as you mentioned, it's sometimes it pays just to wait a little bit longer and stay back as everybody goes to the bleeding edge, or and not let yourself update or continue updating. And so that's great, and I appreciate you being transparent about that, because I think that almost everyone listening has probably gone through something similar to that. And whether it's been with TensorFlow or it's been with something else, we all know those bugs that take 4 months to figure out. And then when you do figure it out and it's like you get it resolved,
Yeah.
you have to pop open a bottle of
Yeah,
champagne.
and I think it's a very interesting question too, just around like the service agreement of open source libraries. I mean,
Yeah.
I think that's an interesting question. I mean, there's a number of kind of core foundational libraries that I think a bunch of us rely on, not just TensorFlow but other ones, and we use them in production. We work for corporations, but we're not really qualified to go in there and dig it and fix it. And but it's very crucial for us to do our work, and so that's an interesting place to be in, I think, for the community.
Yeah. Yeah, that's such a huge point. And that, I guess that's why you see some companies that just devote engineering resources to maintaining certain open source packages if they are so fundamental to the business. So, all right, my favorite part of this whole chat, I want to hear about the war stories. I think we've got just a few minutes left, and for everyone that has enjoyed this conversation, I want to remind you that both of these incredible guests we have on right now, they're going to be presenting at the Apply conference. So if you're not registered already, you can jump in. It's on February 10th, and I'll leave a link to register there. I'm going to be hosting it. I may or may not play some guitar or guide some meditations. I don't know. We're going to let the crowd decide. But what are the war stories? What do we got? Like, Erica, do you have any fun ones? And it doesn't have to be with Etsy. It can be just over this long career that you've had. What are some
I have
painful
an
stories that
ML.
we can learn
That's a
from?
good question. I have an ML related relatively recent one, which is that we had done a bunch of work to make models better. We had moved to TensorFlow, we did neural networks, we added a bunch more kind of transformations to our models. We had really, really stellar offline results. And then we went to go put it online, and we ran an A/B test and saw stellar results when we ran it online. And then kind of halfway through the A/B, the people in the ML platform team had said, hey, I think these models are a little bit more expensive to run. And we're like, okay, but they're doing really well. And then at some point they came back and we're like, we did the math and they're like really expensive to run. And we were like, oh no. And it turns out we had just like blown we just made the models so inefficient. And we would have to throw so many resources to serve them in an online way, that it would not make it worth it, basically, even though they were much, much stronger. And we went into this, like, at the time we hadn't built out tooling to make it easy to identify where in the model code or the feature transformation code the problem was. And we just basically like binary searched. It was this like terrible process. We were like, well, these features look suspicious, or these transformations, let's try to train a model without them, like without 5 of them, without 4 of them, without 3 of them. And we just kind of basically brute force binary searched our way. And because the transformations were also very slow, that ended up being the problem. Model training took a day, model evaluation took like 8 hours. And so it was this like grueling, kind of under a lot of pressure to get these models shipped process. TLDR is that yeah, it was vectorize your feature transformations yeah, don't try. We were using TensorFlow Transform, which is basically you can write feature transformations in Python. You can do whatever you want. You know, the world is your oyster, but you can just blow up your model performance so easily. And there's not great tooling in TensorFlow to identify that. And you can think you're sitting on a huge win when you're not. So.
Yeah. Oh, I was like squirming just listening to that. It's like having to replay that story in my head, and I didn't even go through it. I just listened to it. So yes, hopefully because someone heard that story, they're going to not have to suffer through that like you did. So thank you for suffering through it. What about you, Seoyoon?
Yeah.
You got anything for
I
us?
have a good one. This is probably the most memorable one of my career. So this is naive old me, when I first joined Etsy. Before in our talk, I mentioned that our team was kind of taking care of presentation, backend, all that, other than the MLOps related stuff. So one time I just had to add more ads to a different page, right? So I was like, that's simple. I'll just take the output of this request flow and just tack it onto the page. This is before I knew all of the infrastructure related to just serving ads, fetching features, fetching candidate sets, basically, and then all the traffic that will be placed on that specific page is like, our most heavily trafficked page. So without taking into consideration all of that, I kind of just threw it in there. We do have dashboards we look into before we start ramping up, just to see latency concerns or just impacts infrastructure. So we do like slow ramps whenever we do these types of ramps, and we just ramp it to like a certain subset of traffic before we ramp it up fully. I did notice like a small spike in, some of these graphs, but historically we've seen that before where it just recovers. So, at the time I was like, I think it's going to recover. Let's just keep pushing. It's also late in the day. But then as I was pushing, some people pinged me. They're like, hey, is this you? Is this you? You're pushing this out? All of our infrastructure. I think all of the lower component APIs were being flooded with traffic and hitting like 100% CPU utilization. I think there was chatter in our war room Slack channel about the site being taken down. And then I quickly had to revert, sweating bullets. But yeah, we had to revisit that another day after having a larger regroup with other infrastructure-related teams before we could actually ramp this out. So yeah, definitely a defining experience in my career. Now I know to be a little bit more careful as I push things out.
Like 1 week before I joined.
Yeah, I think that those may have been 2 of the best war stories that I have heard. And so it just shows y'all have been through your share of pain and suffering when it comes to this, because I imagine and all the experience that you have too, right? Because you have to have a lot of experience to be going through this kind of stuff. So it's great to see that, and I appreciate you sharing these war stories because we learn so much from them, and we learn vicarious through your pain. So thank you for that, and thank you for coming on here and chatting with me. This has been awesome. I really learned a ton about calibration. I learned a ton about what y'all are doing at Etsy and how you're doing it. And I look forward to hearing your talk in the Apply conference. So that's it for today. Thank you again, both
Thank
of you.
you.
It's been
Really fun.
it's been really cool.
Yeah, thanks so much for being a great host.